Good afternoon, everyone. My name's Nicole Egan, and I'm a co-founder and CEO of a cyber AI company called Darktrace. And we're going to be highlighting in this session one of our customers, which is CBS Interactive, and specifically how we help them protect against cyber threats during the Super Bowl. Just kind of a quick intro on the landscape of what we're seeing today around cybersecurity threats. The attacks are definitely getting more complex, and they're happening much faster. And this is making it more and more challenging for cybersecurity teams to actually figure out how to stay ahead and defend against all these threats. And a lot of what we see, I mean, you probably hear and read and hear it in your own internal organizations, email still is the #1 threat vector, but we also see quite a bit around cloud and SaaS applications as well. There's also a whole new emerging style of threat. We're in the very early days of it, but it's where the attackers are actually starting to use some machine learning and early forms of artificial intelligence as part of the attacks themselves. They're also looking at new ways to actually attack AI systems. Now, a lot of what you hear about things like, polluting training data sets, but you'll also see some machine learning attacks where they're trying to actually learn people's behavior. They're trying to learn about maybe a conversation that's happening between people, especially if there's money involved, and how to insert themselves in that conversation. But we think we're going to see more of these attacks in the future. What this means is we really have to have a fundamentally different way of looking at security. And this is especially true when it comes to the cloud. Many companies, and we right now have deployed in over 3,000 unique customers in 105 countries, and many of those are somewhere in their journey to the cloud, or maybe they were a startup who started with pure cloud. And there are some unique security challenges in that environment, especially visibility, the fact that you used to almost be able to see everyone and everything that was connected to your environment. And now, especially with IoT, with 5G, that's getting more and more difficult. So trying to understand that contextual nature of what's going on in the cloud is harder than it was on-prem. There's also a lot of use cases, and I think the one we've highlighted here today is a great one where they're continually streaming applications, and the real-time nature, and that's what I love about the example of the Super Bowl. It's streaming, it's real-time, it's at kind of a national and a world scale, and it all happens in 4 hours, right? And you get this whole volume of people in your supply chain and viewers that all of a sudden come flooding onto this environment. So I think it's a real unique example, but many of you with cloud applications probably are up against some of those similar challenges like the real-time nature. And then also making sure you get all the way down into container level visibility. In fact, we issued a press release today that Darktrace is now available for the first time ever in the AWS marketplace, and also we've announced support for the VPC traffic mirroring capability, which now gives us real native capabilities and visibilities for all of our clients from a security perspective. But with this asymmetry of attack, one of the biggest questions when you deal with chief information security officers and CIOs is who's winning, right? If you have all of these things happening at the same time, you've got the fast adoption of cloud, you've got the complexity of the attacks, you've got the AI and the machine learning both for offense and defense, and you have this global phenomenon where at the nation-state level, they're starting to end up being aligned with organized cyber criminal rings. And you also have these very advanced nation-state level tools that all of a sudden get out on the dark web. And now somebody doesn't have to have the same level of skill that they had to have before in order to actually launch a very sophisticated attack. So one of the things we did, and I mentioned AI being an important part of this, we developed an artificial intelligence system that actually emulates the human body's own immune system. Now, what do I mean by that? What it actually does is we use unsupervised machine learning, and we drop it in each of these cloud environments and cloud instances, as well as the SaaS, the on-prem, the IoT environments, and it learns the pattern of life of everything that's connecting to that cloud environment or that network. And it learns it in real time. And once it understands that pattern of life, it can understand when anything changes. Most importantly, it actually can respond itself. Believe it or not, we have it now to the point where it can do a lot of that response to at least slow down or neutralize the threat without a human in the loop, buying the human security team time. So with that, I would love to introduce Floyd Fernandez, the Chief Information Security Officer of CBS Interactive, to talk about how he uses this technology together with AWS Cloud to keep them secure. Floyd?
Thanks, Nicole. So as Nicole mentioned, I'm the Chief Information Security Officer for CBS Interactive. I've been there for about 3 years, and so part of the presentation today is really provide a little bit of context in two things. One, what is CBS Interactive in terms of CBS? A little bit about our journey to the cloud, because that was an important part of looking for a product that basically not only provided assistance within the data center, but also the journey to the cloud. And the third part was really about the Super Bowl and sort of our environment as well as part of that. So a little bit about Interactive. So everyone's obviously familiar with CBS as an entity. Interactive is actually the digital or consumer side of that business. And so when we talk about that, it's really, and what a lot of people don't actually understand, there's hundreds of different web properties under that. So, and under those properties, we're actually the 7th biggest site web-wise within the US, 15th in terms of globally. A lot of those are based on what an independent organization called ComScore that actually does that on a monthly basis based on a number of unique users. So we process somewhere around 200 million unique users a month. Those comes from everything in terms of our registered users or assets in terms of the web properties. And in the next slide, I'll cover a little bit of those properties to give you an idea of the breadth and sort of the scale of what we're trying to do. Because when you think about most organizations, they probably have a handful of actual properties or applications. You start to multiply that in sense of the hundreds of properties we have, each property having multiple applications, each application having multiple or hundreds of microservices. So when you start to look at that scale, one, they're all different because every property is sort of either categorized in one of 3 different ways. It's either static content in terms of our sites like Tech Republic, CNET. There's others in terms of our streaming aspect, in terms of CBS All Access or Showtime. And then there's the live stuff that we'll talk about in terms of the Super Bowl, but also things like our sports site, our news site, that's basically 24/7. So it provides a unique perspective of the different type of properties that we have to cater for. And again, think about the fact that from a stack perspective, if we look in the technical portion of it, that stack is completely different for each one of these. So when from a security aspect, if we're trying to look at a foundation or a starting point, that baseline is different for every property. So when I talk about risk, I talk about business risk, and that business risk is actually applicable differently to each one of those properties. Okay. I covered this. This was basically just a sort of snapshot view in terms of what those properties are. As I mentioned, we sort of fall into sort of the 3 major categories in terms of streaming, static content, or live content. And so with these brands, they were all within the data center as we started this journey. We have multiple platforms as I'll sort of walk through this process. And so that provides another unique aspect of when you're looking at the fact that there's also collaboration between some of these sites because there's sort of an underlying internal engine that's provided when you look at, for example, processing video or processing a registration system. Or processing just what is a static content. Each one of those elements is part of a layer within that environment. That's there. So a little bit about the cloud journey to the cloud. So historically, most organizations really are looking at moving to the cloud really based on cost cutting. In some sense, that was a significant portion of our journey as well, our strategy, because coming back to the fact that most of what we do is event-driven. So think about the Super Bowl. It only happens for 4 hours. We host the Grammys. It's, again, a single-day event. March Madness only runs for about a month. So if you're in a data center, one of the problems with it is that how do you forecast or do you purchase equipment for a single event for the case of for the next 12 months? Not a very effective model in terms of what you're trying to do. So that sort of started the journey. The other parts of it was really about innovation. It's the ability to scale and deploy as we need because of each of these event-driven approaches. As we sort of moved into the different approaches of the cloud, we also started to understand, okay, from a security view, how do we look at having a single policy applied to multiple different properties? When there are different elements, there are different processes, and there are different registration systems, there are different types of users, and there's different type of content. So you sort of take a step back and you really try to figure out what is the content I'm trying to protect, ultimately at each one of those properties. In some sense, it's going to be PII information that we collect about a user. In another, it's about the fact that we're sharing some of that metrics in regards to one of our revenue models happens to be the ad network. So again, there's audience data that's collected there that's used for marketing, it's used for other purposes. So again, the policy, while it at an umbrella level is the same, you have to figure out what you're actually looking for at each level. Okay. So wanted to step a little into challenges. So one of the key things of trying to go to the cloud was really about two things, and I always put it into two buckets because one is really based on what we call accounts. So when you look at the world of AWS, there's multiple accounts in terms of how many accounts do you have for each of the business units. For our circumstances, think about, again, as I said, it's about scale, right? We've got hundreds and hundreds of accounts for each one of those properties. Under each one of those properties, there's hundreds and thousands of instances. So if I'm looking at trying to understand that landscape in terms of under each one of those VPCs, how are they connected, interconnected with each other, how are they connected back over something like a direct connect back to our data center, how are they connected back to third parties that are plugged in to our ecosystem. And I'll talk a little bit about the supply chain there because when you look at the media industry, it's really made up of hundreds and thousands of small businesses that are provided services as you sort of move from sort of shift left in regards to the trajectory of thinking about how you shoot something on site at a studio, how that image is uploaded to a post-production house. You've got the pre-production, you've got all the different marketing advertisements, and then you actually stream the application or launch it. Each one of those, in terms of the first part of that equation, is actually all farmed out to small businesses. That small business then can actually farm it out to multiple other businesses. And all those businesses have to be interconnected back to us because ultimately we're sharing that data along the pipeline as we're working through our way. So one of the challenges with this was the fact that when you've got so many different accounts that are peered together in the world of AWS, it's peering, we really needed to be able to see the data that was connected as one entity was talking to another, whether it was internally within Interactive or whether it was externally within a third party or within our supply chain. So that sort of brings us to, well, why Darktrace? What sort of got me looking at a vendor out there to be able to address some of these challenges that we wanted to. And I sort of really looked at 4 key points here, and I'll elaborate why I sort of narrowed it down to the scope of what I call the scope in terms of why we found Darktrace. So first of all, I started off with really looking at sort of the right-hand side, or sort of the left-hand side of the screen there, in terms of what do I mean by human expertise and what do I mean by innovative technology. The media organization is basically not one of the financial industries that has thousands and thousands of employees, whether it's in operations, whether it's in architecture, whether it's in security. We end up having to do a lot with a few people, but ultimately we're very heavily dependent on talent that can actually utilize a lot of the processes and technology. So whatever I was looking for had to be technological advance in terms of being able to minimize the headcount for what we're doing, especially when you're starting to look at a larger footprint in terms of what is that data that you're ultimately trying to protect and see. So that really came down to intelligent data. That when you look at the cloud, you're logging everything. All of a sudden, in the old world where you had a log server where you logged everything, that was already unfeasible. Think about how it happens now in the cloud where you've got probably 10x to 100x of those logs. So logging is not necessarily going to give you the visibility in terms of the SIM world that we're used to there. So it was really about figuring out with everything that you're logging and everything you're seeing, how do you extract the actual information? So in the Darktrace world, as Nicole sort of mentioned, it's really about, and I'll talk a little bit about the infrastructure on the next one, it's really about taking that data that's being collected within the Darktrace model and figuring out what is the baseline, what are the anomalies that it sees as part of the machine learning and the AI aspect of that. Continuous being a huge part, because obviously as we're deploying not only new properties, but we're scaling up, which is a large part of what we do for a single day event. The normal trajectory is pretty static content throughout the day in terms of traffic, scale up for a couple of hours, and then scale back down again. So again, coping for that volume as that data comes in and is being processed. The predictive part was, can we find a product that's going to sort of get us to sort of what we call the false positives, remove the false positives, to be able to really be able to get a single individual, the frontline human interface person, to be able to analyze the data that really only matters. And so as part of the machine models that you're building, you're targeting a model for each one of the web properties to figure out what is the kind of data that property historically sees as part of the baseline, and target that as an alert within the system itself for Darktrace. Actionable. So what we wanted to do with actionable was really take the alerts that were coming out of it and basically merge that with the rest of our information in terms of the stuff that's collected from CloudTrail and our SIM and some of the other security products that we're looking to be able to piece together sort of what an individual is doing or what a third party or a product or an application is doing across from start to end, because that's sort of the only time you can actually make something more actionable in terms of being able to address the problem within your incident response team. Sort of jumping into the Super Bowl. So we use the Super Bowl as a great example. I'll give a little bit more background here. So with the Super Bowl, the way it works is that every 3 years, CBS gets it. And so what happens is there are other broadcasters that get it in the other years. So when it was last held in terms of the Super Bowl 3 years ago, we actually hosted it in the data center. So there was also a new environment in sense of, as part of moving to the Super Bowl, we had to have not only the fact that we were getting it after 3 years, we were also going to take it from the data center into the cloud for the first time. And so as part of that, it was actually the highest streamed event for the Super Bowl to date. And so that was 100 million unique users, million views as part of that. Sort of a couple of stats in terms of how many viewers we had per minute. A lot of this, remember, in sense of the type of traffic we saw was, in fact, probably an hour or two before the actual show started. People were wanting to sort of log in, and actually it ramped up throughout the day and as the game went on. One of the unique things that probably people don't know is that we actually streamed it on 2 separate, completely different platforms. One platform is really on the sports platform, which is based on the fact of it was free to air, or it was a free platform. The other was part of our all-access streaming application in terms of the fact that it was a paid model. So 2 separate environments to look after, 2 separate environments to understand who are all the different parties that are actually connecting into this environment to make up this environment, the game itself. So start with the foundation. So the reason I put this in here was to understand that, okay, if we're going to the cloud, we're setting it up for the first time, this is an event that's only going to happen for 4 hours, the prep work for this actually starts a year in advance. So one of the things that we're also, in fact, in the new year when we come back is we're going to actually be getting the Super Bowl back earlier this time in 2 years' time. So in 2021, we'll be hosting it. So we're going through this process all over again in terms of working with the different parties. And so starting with the foundation was really about, how do I understand all the third parties that I'm working with? Do I understand the different platforms that have been built? Because one of the things as part of the journey to the cloud that we actually did was we actually refactored everything. We also went from a VM platform to a containers platform. So everything in those elements was also brand new. So it was trying to get insight into understanding the new environment, what was the type of traffic across our containers, and what was the traffic basically being shared in terms of the third parties that were all connected. That could be anything from our video suppliers, our CDN providers, through to all our support staff that actually help us on the day itself to make sure the environment actually runs the way it is. So as part of that, it was also a case of a lot of these individuals were actually going to be in our office, connected into our network to be able to help support that. So when you start to look at the different elements that I'm talking about that are being plugged in, we have everything from video equipment. One of the things I didn't mention also is for some of our other sites, for example, like CNET, the main criteria of what they do is they basically review technology. That technology has an IP address. It's plugged into the network. You look at IoT, very similar. We have different devices that are throughout the network and throughout that event that are plugged in, everything from the stadium through to the trucks, through to the post-production houses, through to the video center, through to interactive, throughout to the streaming aspect. So that's sort of the flow in terms of what I was going to cover there. Live event streaming. So this is very different in terms of understanding that most of what you look for in most people's environments are video on demand is probably the most common thing. Very different environment when you're trying to do live. There is no room for basically for the event going down because you're expecting it to be alive. So in some sense, again, you can't necessarily depend on historic data when you're looking at a live event. You have to have real continuous information about the data. So that's why, again, going back to that scoping exercise that I did in the previous slide, we were looking for specific items in terms of being able to create a data model or a breach model to trigger the kind of things we would see in each of the platforms as the data moved from sort of the site itself through the partner networks out to the actual customer itself. And so one of the things that we also monitor, but a lot more remotely, is that obviously as part of streaming, we're basically looking at over-the-top devices. So these are your Apple TVs, your Roku devices, your Fire Sticks. Those are all endpoint devices in the world that we're looking for, understanding are they a threat vector as well in terms of what is connected to the network as we're streaming that. And in terms of the Super Bowl, I sort of covered this in the supply chain. The idea here is that you have a mass set of vendors that you're working with as part of that supply chain. Each one of them are coming in through different areas, whether it could be a VPN directly connected, a B2B network, or permanently connected through as part of a partner network. So the idea is, how do you get that visibility when it's only a short event where we're wanting to try to restrict when they're on the network? So again, for an event like the Super Bowl as an example, we're really only going to get them on our network for 24 hours because that limits the scope, limits the risk in understanding how those devices are connecting, what are they basically doing on our network, and how they're transferring data in and out as part of this event. Connectivity. So when you think about connectivity, what we also started with as part of why we sort of went with Darktrace and when we sort of moved over to the cloud was sort of based on these four things. When you think about the cloud, it's based on common things like SSHing into a box, being able to VPN, HTTPS, or VPC. Those are sort of your four, what I call the choke points of where you really want to be able to have something in terms of, if we talk about the Darktrace model, it's an OS sensor. So the infrastructure setup, if we look at Darktrace, is it's based on an OS sensor on a host. It's based on a vSensor, which is a sort of a collection point from the OS sensors to the vSensors, and then that goes back to a main console. And so now, as we look to what AWS has done in terms of being able to plug into that network in terms of the VPC pairing, we're also trying to be able to get some more data, because obviously one of the things that when you move to the cloud, you lose that ability that you had in the data center to be able to plug into the network layer, because it's obviously not owned by us. So that's one of the other key points of making sure that from a connectivity, we're starting to see everything that we can, even when we don't necessarily own the network. So it takes us to next. So I covered most of the points in terms of the supply chain, looking at sort of the web, looking at sort of, what Nicole mentioned, email is one of the other areas that they do a lot. So these are some of the other points that were sort of covered in terms of what else you can look for in terms of Darktrace being able to give you that key visibility and the understanding of what's happening on your network. And when you look at this list, it's all the common security threats you tend to have, whether it's an endpoint device or whether it's information in terms of the network kind of behavior or the malware that's connected there. So as you're building out what's called a breach model in each one of these events, you can start to be able to target these first out of the box. One of the good things with Darktrace is that it's continuously learning your environment and it's continuously highlighting through the main console the areas that you need to focus on, and then you continue to build the modeling on top of that. Future threats. So as we sort of moved from the data center to the central cloud, one of the other things that we're focusing on as being a media provider and as a streaming center is that we're moving more and more data to the edge. And so as we move more data to the edge within CDN and the approach of the 5G coming on board, we also want to get visibility into those areas because we've now exposed what was initially, so if you think about the analogy of the data center, it was always sort of a hard shell around an egg. That hard shell disappears as you go to the cloud because it becomes more permeable in terms of what's being able to allow to connect. As you move that data further and further out into your partner network, and whether it's the CDNs or it's your 5G, you lose more control over that. So it means stretching your visibility further out into these points is probably going to be ideal for us to be able to understand what are those different points outside of our control that are connecting back into our network. And the last one here is about resilience. So one of the common things that we think about in the security world is you're inevitably going to get compromised. The question is, how quickly can you react to that in terms of understanding where's ground zero, who's the threat vector, what kind of information is the lateral movement. So one of the key things with Darktrace is that you're actually seeing east-west traffic, whereas generally when you think about most of what we monitor on the network side, it's only north-south in terms of your firewall, your IDS, your IPS. So this is thinking about more holistically the traffic that's moving in all four directions, because when you think about a compromise, it's always based on lateral movement. So you really want to be able to see that lateral movement there. Okay. Yeah, go back into Fireside Chat.
Thank you so much. And I think what we'd like to do is go a little deeper into some of these during a conversation. Then we'd also like to open it up for questions to our audience. So grab a seat here. So I know you said CBS gets the Super Bowl every 3 years. This time will be a little bit sooner. But you also mentioned to me that you kind of almost made a game day decision when you were actually going to decide to be brave enough to stream it live through the cloud. And you said that decision wasn't really made firmly last time until about 3 months before game day. So what were those 3 months like, and what went through your mind in terms of, because it is such a highly visible event and it's so real time, what could have gone wrong and how did you get out ahead of that?
Yeah, so one of the things obviously, as I mentioned, is that we prepare a year in advance in terms of understanding, okay, we've got the Super Bowl, what is it going to look like, how is that platform going to be built out? And so one of the decisions that was made later on was really about scale ultimately. We were in the fact that the cloud was going to give us that scale. It was also a case of understanding that, okay, while we hosted it in the data center 3 years ago, if we had an unexpected sense of not necessarily knowing how the traffic was going to be. And so one of the things that I mentioned was, how do we forecast for that? So we had to make a decision of, are we going to buy hardware for basically one event that's basically going to sit idle after the actual 4 hours programming, or do we buy something where we can scale up and down for that event? But at the same time, the decision was also made to go from, as I said, VMwares to containers. So it was also taking not a lift and shift approach, it was taking a refactor approach. So there are multiple elements that were decided, I guess to some extent fairly late in the game, but it provided us the flexibility that we ultimately wanted to be able to know that, yes, we could pull it off in terms of having that event regardless of the size that it was going to go, because it was an unpredicted amount, but also gave us a great understanding of what can we do for the next 3 years in terms of when we host the event again in terms of lessons learned.
Yep. So another key area, you mentioned CNET and how there can be just a lot of testing of new technology. But overall, CBS Interactive, I know one of the challenges you mentioned is from a company culture perspective, you guys like to really embrace leading edge technology. You like to let employees bring whatever into the environment and kind of plug it in and test it out. So how do you deal with that? Because a lot of these IoT devices, you can't possibly put an agent on.
Yeah, and that's one of the things, right, is that when you look at what we do as a tech company, ultimately, even though we're a media organization, we're actually a tech company at the end of the day, and regardless of whether it's CNET or whether it's the video side or whether it's the broadcasting side, everything that's brought into the environment isn't necessarily got a homegrown, it's not one of your common operating systems, so you can't put an agent on there. So one of the key things of finding a solution, which is how we sort of came across Darktrace, was being able to have that visibility, being able to not necessarily be dependent on an agent, because you wanted to be able to see anything that ultimately had an IP. And when you think about the IoT world in terms of OTT devices or any of the tech that CNET brings in, whether it's a camera, an IP camera, or even if we start to look at internally how we manage our corporation, like most other corporations, everybody's moving to IP cameras for security. Everybody's got a badging system. So all of these other devices that are slowly coming onto the network, you talk about printers, photocopiers, everything is now sort of an attack vector or has got a vulnerability. And really you want to be able to have something see all of that, but also be able to map it and sort of distinguish between categories. And that, I think that's the key part about it is, one, it's not only visually seeing it within something like Darktrace, but it's being able to separate where within the kind of categories you got, where's my most pertinent risk that you're saying.
Now you mentioned that there's all those different properties. I thought what was really interesting is that they're operating different technology stacks and business models to a certain degree, and while the cloud has helped kind of normalize that a bit, how does the machine learning play a role in learning what makes each of those 20 different properties and business models unique?
Yeah, and so I touched on that in terms of what I called business risk. So within each one of the properties that we look at the risk, the model that's being built out as part of the machine learning tends to create that baseline. So we have a great baseline in terms of each one of those web properties, whether it's a static one, whether it's streaming, or whether it's live, to understand, well, what are the connected devices that are part of that property? Which devices are the noisy ones? Which ones are talking to each other, but which ones are also what I was talking about in terms of lateral or left, sort of east and west traffic, where they're sort of not necessarily talking application to application, but out to all the third parties that are part of that ecosystem.
Now I know this is an area you probably can't say a lot about, but one thing is that this is a worldwide event. There's physical security issues along with cyber. How did you have to interface with someone like Homeland Security for something of the scope and magnitude of the Super Bowl?
Yeah, so that's one of the things that we do as part of the sort of the 12-month ramp up to the event itself, is that we're working very heavily with the Department of Homeland Security. There's all the physical aspects of the stadium itself, as I mentioned, the broadcasting trucks, all of the sort of permanent connections or temporary connections, back to our studios and then back to the digital version ourselves. Besides sort of the logistics and the nightmare of all that planning, we also have to sort of understand who those different players are and be able to also provide that documentation. So one of the key things is when we talk about network visibility, it's really that map of what are the different elements that are actually not only connected as part of this environment, but which ones are the temporary ones that are going to come online for the day. As I mentioned, one of the things is we must have had a couple of hundred people in our office on that day. They were all third parties. They're bringing their own laptops. They're bringing their own devices, and they're basically plugged into the network just for the sake of the 4-hour event, and then they're going to go away. You can't necessarily, in most cases, get them to put an agent on their machine or be able to do anything else. So it's really about understanding that traffic that's happening within that short span of time.
Interesting. Another interesting area for CBS right now is, and I know you can't say a lot maybe about it, but publicly it sounds like the Viacom-CBS merger will close later this week. So what do you see kind of from a security perspective of, I assume usually you have to connect environments together, and any security risk can come from any place. So what do you see as the challenges as you kind of, this massive merger comes together and brings these
Yeah, I mean,
problems?
as you sort of look in the media industry, obviously there's a lot of acquisitions or mergers happening right now, and I think this is pertinent to anybody that's sort of joining two companies, whether it's us or somebody else, is that it's an unknown state. Each organization has a good understanding of their security, but obviously as part of something like that, you're connecting email systems, you're connecting financial systems, you're connecting all the back-end elements that not necessarily have a known quantity, so the risk is unknown. You're also trying to find areas where the policies might be different based on culture. So I think that's a key element of being able to very quickly have something like this deployed to get a baseline at the end of the day on sort of a, well, let's sort of not necessarily a day one approach, but as you're going through the integration, you have an understanding of what is known traffic that's within your environment and what is not known that's coming from another party.
And outside of things like the sporting events, the other shift that we're seeing is a lot of new original content. How does that change security as you have new players that you're starting to work with, new vendors, a lot of startups, and just a lot going on in that original content area? Yeah,
so one of the lessons we sort of learned even prior to the Super Bowl was really around Star Trek. So Star Trek was launched in 2017 as an original for CBS Interactive on the streaming platform. And so that was a great lesson in terms of looking at the entire supply chain that I was talking about. We had to work with the hundreds of vendors, everything from the studio lot where everything's filmed, to the writers, to the script editors, to the post-production houses, because they're at some point or another coming onto the network as part of their process, because they either have to have the script from a written format to a digital format where they're sharing, or there's something that's recorded and then it's being sent out for production, or it's being finally transferred to us where we're then sending it out to sort of like a CDN to be able to process, or we send it to third parties who then have to also maybe do an international launch for us where we don't have a licensing agreement. So again, that interconnectivity of the multiple people handling a single video file is alarmingly, it sort of makes you very nervous in understanding what that flow looks like. And that's, again, when you sort of think about most organizations, it's hard enough to map out all your vendors. It's even harder to map out what that workflow looks like from start to end.
Great. Well, we covered a lot of ground, but are there any questions in the audience for myself or Floyd? Yes, over here in the front row. So the microphone just got to you. Sorry about that.
Can you talk a little bit more about how you use Darktrace and the products or tools that Darktrace provides to secure your environment?
Yeah, sure. So as I mentioned originally, we started off on the data center. So and the product, Nicole can talk a little bit more about this one, where sort of the inception of where it came in from. In terms of the network deployment, it's basically an appliance that sits within your network. It basically, you feed it the subnets, and it basically starts data collecting immediately from there, and it's starting to build the models from the time that it's given the range of addresses that you've got. In the cloud, the way we basically deployed it was we looked at the OS sensors, and we deployed those on the hosts in terms of the instances, the EC2 instances, or within the Docker containers. Those all feed into, as I was mentioning, into the vSensor, which is a data collection point that then actually does the analysis that actually then sends it to the main console where you basically get the machine learning model that's generating the alerts and the threats that you've got. So that's sort of the deployment method that we've used. And so and the reason I describe both of them is because for what we've done in our offices, we've deployed the host version, the appliance version, in the sense of being able to see everything that's happening on your office network in comparison to your data center networks and your cloud networks.
Yeah, so there's multiple ways you can really use machine learning, artificial intelligence around cyber defense. The first phase is definitely using the AI to find the threats. And there's two kind of camps out there in the marketplace. One camp uses what's called supervised machine learning, and it learns off of a historical attack data. So the idea is you try to take all the data and all the attacks, you throw it up into a cloud, you analyze it. And while that's useful, and I think Floyd's example of the Super Bowl is a great one, yesterday's attack on somebody else may have no bearing at all on today's attack or tomorrow's attack, right? And so that method to us looked too much like rules and signatures in the past. So we actually came at it from a different angle, and we decided to use the machine learning to learn each unique environment, whatever that environment is. And that environment can be a mix of on-prem, cloud, IoT. We even cover things like SCADA environments, industrial control systems, because the machine learning, the AI, doesn't actually care what the data is it's analyzing. It just has to learn from that data to build that pattern of life. And so you're able to see unique attacks that have never been seen before, or insider threat, supply chain threat, configuration errors in the cloud that you wouldn't be able to see if you were just analyzing historical attack data. So that's kind of the fundamental different approach. The other thing that's pretty interesting, and Floyd touched on how no one has enough resources to deal with these security issues, and everyone seems stretched very thin to find the right kind of talent. We've actually gotten this AI now to also learn from world-class threat analysts. So we employ over 100 threat analysts from FBI, NSA, GCHQ, MI5, brand new college students who are trained from the beginning on working with AI to analyze these threats. And we actually now can reduce by 92% the threats that a human even has to look at. And that's why I said we can do so much of this now actually with the human out of the loop until it's really something that it flags up and says, okay, now I need a person who can go deeper in this and add greater context to the business risk.
And that's a key point that Nicole touched on was the false positive. That's a key part of it. The false positive is lowered, and as part of the support that we also do is that expert analyst basically can do a deep dive into it and send us a report as well. So that's another key part, is because you're supplementing that talent by sort of leveraging not only the platform, but a deeper understanding from Darktrace itself in terms of what that threat looks like.
We have a couple more minutes. Any other final questions? Yes.
I don't know if you can share how many threats were shut down by Darktrace during the last Super Bowl.
Unfortunately, I can't share that.
Yeah, he can share specific ones. I think that what's interesting is I can give some examples of, we actually published threat reports, so we tried to take the most interesting, unusual threats that we see, and we actually publish them on Darktrace blogs, and also there's threat reports that we publish. So if you like to hear kind of the really unusual ones that are out there, either the threat reports or the blogs, and especially there's a whole new one we published on IoT devices. One that's been interesting in the past couple months, we've seen this probably more in California so far than other places, is we've actually started to see people connecting their Tesla cars in parking lots to guest Wi-Fi. And initially we were like, okay, this is really strange because it's not even in the building, it's in the parking lot. What is going on? And it turned out, it started pretty innocently, where people, instead of charging their Tesla at home, they decided to use a charging station at work, and they upload, I guess at the same time, the telemetry data about their driving habits, to Tesla. And so it's kind of concerning, but all right, it's just using guest Wi-Fi, probably shouldn't be doing that. But last month, we actually saw for the first time somebody actually exfiltrated data out through the Tesla in the parking lot and stole corporate information, or tried to, and Darktrace spotted it, and our autonomous response kicked in and stopped the data exfiltration to this unusual device, which happened to be a Tesla. But there's all kinds of interesting ones out there. It constantly changes. But that's another example where it's not something anyone was looking for, but yet the AI can spot it in real time and actually pause it or put a stop to it until a human can take a look at it. Yes.
Yeah. Can you talk a little bit about the assessment of the supply chain, the new supply chain, when you added it to the CBS? I mean, what kind of assessment you?
Sorry, could you repeat that?
The assessment of the new supply chain, when you added a new supply chain to CBS, what the step you taken to add a new supply chain?
Yes, so what we did is once we've identified who those vendors are, we look at the point of entry. So generally the easiest place is to look at where they're connecting into your network, whether that's through a direct connect, whether it's through a VPN service, whether they're physically on your environment. Because the idea is that you want to be able to see the traffic when it's either entering or leaving your network. Because in most cases, it's a lot harder, obviously, to get them to deploy something. But because it's network-based, you're actually seeing it at that perimeter. So a good example sort of within the AWS world that I was giving was when you look at the interconnect or the peer-to-peer between a VPC and another VPC, there's a transition there, right? So you want to be able to see that traffic. Very similar. Think of that as your supply chain network. You want to be able to see everything that's crossing that peering network. And as the model builds up, you'll start to get the areas where you start to see an anomaly. And so one of the things, while I can't talk about some of the threats we see, it's pretty fascinating on a daily basis. You'll start to see user behavior where you would not necessarily expect it, because this will filter the noise out and actually get you that individual or that device that's come on the network that's doing something that a user necessarily isn't aware sometimes.
Any other questions?
Yeah. Once your machine learning model recognizes a risk, how does it actually respond to it? Like, what are some of the different ways that it, what does it do, I guess?
Yeah.
Curious, yeah.
Yeah, so the first thing it does is learn the pattern of life. It uses that to then find these unusual patterns. It uses, each of the AI models actually usually contains anywhere from 12 to 15 different mathematical approaches. We use something called new Bayesian estimation over the top of that. So at that single point in time, based on that data at that moment, it actually determines which math model has the highest degree of accuracy. So there's a lot that goes into this to actually keep the noise out of the system. Once it does that, it will create a threat, and you can have an option where you can have a human threat analyst or someone in the security operations center actually be taken right to that threat at that point in time. It has a playback system. You can actually watch what happened leading up to that security incident, what happened since, which other parts of the system have been impacted. Or you can also elect to have what we call a cyber AI analyst do the investigation for you. So you can actually have the AI take it a step further, do the investigation, and narrow it down. So an example of that is there was one cloud-related incident we saw where somebody was purposefully trickling out an extremely small amount of data consistently out of the cloud over a 2-month period of time. And to be honest, even some of the world's best kind of human threat analysts, this went missing because it was so subtle, so silent, and so kind of long running. And the AI was actually able to not only pick up on that, but it was able to kind of work backwards and see exactly where it was happening, how it was happening, and be able to do the full investigation and then surface it to somebody in the security operations center. But the final area that I think is the real future of cybersecurity is an area called autonomous response. And the idea of autonomous response is very much kind of similar to self-healing, right? This idea that once it actually detects the security incident, runs the investigation, why not be able to have it figure out what action to take? So out of the 3,000 plus customers we have roughly 1,000 of them using this autonomous response capability. And what that means is they're actually allowing the AI in split seconds to make a decision or a recommendation about what action should be taken. And often what happens is first customers run this in what we call recommendation mode. Just watch what the AI recommends. And once you see this making the right recommendation over and over again, usually that builds trust between the AI and the human security team to actually allow it to start taking action. In terms of actions, it can take actions itself. It can hand off to other things that sit in line, including firewalls. Some companies invest in things like SOAR automation playbooks. It can hand off to that. It can actually do a reset. There's lots of actions depending on the environment that it can take. A great use case for autonomous response is cloud with like configuration errors, where maybe a simple configuration error was made but could have a pretty significant impact. Wouldn't you love for it to be able to actually take action on that and have a human look at it and fix it? I think other examples, an obvious one is ransomware. Almost every one of our clients that uses autonomous response uses it from ransomware, because what you want to be able to do is detect if some unusual device is starting to connect to the backup server and try to encrypt, data. There's no reason for that, and it automatically can cut off that connection and stop that from happening. Email's another great one. I mean, 100% of our email customers use autonomous response because the volume of emails just too great. So I think as you get into the speed and scale involved with things like cloud and SaaS applications, I think autonomous response is the only way that security teams are going to be able to keep up. Any other questions? Oh, we have one right behind you.
Oh. Hi, Nicole. Just curious on the history of Darktrace. When did you guys found the company?
Yeah, thanks. We started the company about 6 years ago, so in 2013. And it actually, the other founders, in addition to myself, came from two groups. One group was actually GCHQ and MI5. And interesting enough, their project before they came to Darktrace was securing London for the Olympics. So I guess we have a lot of passion around these types of sporting type of events. And then the other group are actually machine learning and artificial intelligence experts and mathematicians from the University of Cambridge. And we actually currently employ over 30 PhDs in AI, which for, we have 1,000 employees, but for that many concentrated in our R&D center, it's quite significant. And really, we learned, from the folks that were defending at the nation state level, the whole mindset that you can keep all the bad guys on the outside is just impractical. We heard about just how many people in the supply chain need to, connect up on a regular basis to CBS Interactive. And that's true everywhere. There's no way to keep everyone on the outside. And so if you change this so that the machine learning and AI can show you these subtle, unusual issues in your environment, but then again, have enough data to know when it's a real concern or incident, that makes a big difference. But these are very, they're great cloud, big data kind of applications in that there's a lot of information that has to be processed through these AI algorithms to be able to make this work.
Just to give you an example of the speed of what it's detecting. So in the last 2 times that we've had a red team exercise done, that's obviously very subtle. It's very done in a way not to trigger any alerts. In both instances, we've been able to catch them because the AI engine has done that alert very quickly. So that accuracy and that speed is really fundamentally a great example as a proof of concept.
Excellent. Well, thank you very much for attending. We really enjoyed the session. Thanks for all your questions. Thanks.